Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video I will show another example on heat equation, but this time around it will be on case B. Okay, where both ends are insulated. Okay, and again this is a partial equation and it's copyright to UiTM. Okay, so right now the temperature distribution UST along a thin wire of length 12 cm. So right now we know that L is equal to 12. It's governed by this heat equation. Okay, solve for UST if the wire is well insulated. Okay, case B here, at both ends and satisfy the following conditions. Del U del X, which means UX 0 T is equal to 0, and next del U del X equal to 0 and X equal to 12, which means UX 12T is equal to 0. And the initial condition US naught is equal to 2X for X between 0 to 12 and T greater than 0. So we need to start by letting UXT equal to S of X T of T. Okay, where USS equal to S double prime X T of T and UT is equal to S of X T prime T. This one we determine using, we obtain using the partial differentiation. Okay, so next substitute USX and UT in the given PDE, which is this one. Okay, and hence we have this equation. Okay, and using method of separation of variables, okay, we separate terms of X in X with X and terms of T with T, and equal to negative lambda squared, which is a separation constant. Okay, so here it will be S prime X over S of X equal to negative lambda squared. Rearrange this equation and hence we will have this equation here, and apply the auxiliary equations or characteristic equations, and therefore we have m squared plus lambda squared equal to 0, and then we have m equal to plus minus lambda I. So therefore S of X is equal to A1 cos lambda X plus A2 sin lambda X. Okay, and for function of T, we have here T prime T over T of T equal to negative lambda squared, which means here it can be rewritten as such after we rearrange. Okay, and then again we apply the auxiliary equations or characteristic equations, and hence we have m plus lambda squared equal to 0, where m is equal to negative lambda squared. Okay, therefore we have T of T equal to B exponent negative lambda squared T. Okay, for your information, these constants are up to you whether you want to use A, B, C or D or else, but this is what I will be using hands on. Okay, right now thus UST is equal to S of X times T of T. So rewrite this S of X times this one T of T. Okay, so first we apply the first condition, which means UX 0T equal to 0, which is S prime 0 T of T equal to 0. Since T of T does not equal to 0, therefore S prime 0 equal to 0. And we have this, our S of X. So we just need to differentiate X with respect to X in order to get S prime X. Okay, and hence we have negative A1 lambda sin lambda X. Okay, after we differentiate the first term, and the second term we differentiate, we have A2 lambda cos lambda X. Okay, since S prime 0 equal to 0, which means we need to substitute 0 in S prime. Okay, so negative A1 lambda sin 0 plus A2 lambda cos 0. Okay, sin 0 is equal to 0 and cos 0 equal to 1. Therefore, we have A2 lambda equal to 0. Okay, lambda equal to 0 or A2 equal to 0. Okay, we solve for A2 equal to 0 first. So here for A2 equal to 0, S of X will be equal to A1 cos lambda X. Okay, you can also write the full UST here, which is uxt is equal to a1 cos lambda x times b exponent negative lambda squared t. Because for, let's say we have a2 equal to 0, so we are left with the first term multiplied with b exponent negative lambda squared t. Okay, next. Apply the second condition, which means ux12t equal to 0, x prime 12 t of t equal to 0, t of t does not equal to 0, and therefore x prime 12 equal to 0. Okay, so earlier we have obtained x of x equal to a1 lambda, a1 cos lambda x. So right now we want to determine x prime x. So we differentiate this x of x. We have negative a1 lambda sin lambda x. Okay. So since we have x prime 12 equal to 0, so here x prime 12 equal to 0. Just substitute 12 in x. Okay. So we have negative a1 lambda sin 12 lambda equal to 0. Okay, since a1 does not equal to 0, because if a1 equal to 0, it will be trivial. Solution then. Okay, there will be no solution. So a1 does not equal to 0. And therefore, lambda equal to 0 or sin 12 lambda equal to 0. Okay, we solve for this part first. So here, sin 12 lambda is equal to sin n pi, because sin n pi equal to 0. So we compare the angles. Okay, and hence we have 12 lambda equal to n pi, and therefore lambda is equal to n pi over 12 for n equal to 1, 2, 3 until infinity. Okay, and rewrite s of n, which means here it is a1n cos, okay, substitute lambda n pi 12, so it will be n pi x over 12, and here t of n is equal to bn, okay, b of n exponent, okay, negative lambda squared, which means n squared pi squared over 144t. Okay, for n equal to 1, 2, 3 until infinity. And therefore here we have u and xt is equal to an, okay, cos n pi x over 12 times exponent negative n squared pi squared t over 144. Okay, you need to define here what is your an. So where an equal to a1n here multiply with bn, b of n. Okay, for n equal to 1, 2, 3 until infinite. Okay, next we need to solve for when lambda equal to 0. Okay, for lambda equal to 0, we need to restart again from the PDE. So here we have x double prime x equal to 0. And using auxiliary equation, we have m squared equal to 0, where m is equal to 0. That means the root is on 1 and it is real. Okay, so we have x of x equal to c1 plus c2x. Okay, and for t, we have t prime t equal to 0, and therefore m equal to 0. Here we have t of t equal to c3 exponent 0, which means t of t equal to c3. Okay, and thus uxt would be at c1 plus c2x multiplied with c3. Okay, because x of x times t of t. Okay, we apply the first condition, which is ux 0t equal to 0. So rewrite everything again. S prime 0 t of t equal to 0. T of t does not equal to 0, which means x prime 0 equal to 0. Okay, s of x here is equal to c1 plus c2x. So differentiate x here with respect to x. We have x prime x equal to c2. Okay, the first condition is x prime 0 equal to 0, which means c2 equal to 0. Therefore, x of x will be equal to c1 only. Okay, and then apply the second condition, where ux 12t equal to 0, which means x prime 12t of t equal to 0. T of t does not equal to 0, and therefore x prime 12 equal to 0. Okay, here x prime x equal to 0 here, right? Okay, why we have 0? Because here s of x equal to c1, differentiate constant will be equal to 0. Since s prime x equal to 0, by right s prime 12 is also equal to 0, which satisfies this condition. Okay, And here, okay, a bit of mistake here. And therefore, s prime x here is, okay, this one is not s prime x. Therefore, s prime x only is equal to C1. Okay, and therefore, s of x here is equal to C1. And thus, we have here uxt equal to C1 times C3, where it can be written as only one constant, which is C4. Let it be C4, where C4 will be C1 times C3. Okay, next. Okay, therefore, we will have u and xt equal to C4 plus a of n cos n pi x over 12 exponent negative n squared pi squared t over 144. Here, we will use the superposition principle, where we have uxt is equal to a naught plus summation n from 1 to infinity a n cos n pi x over 12 exponent negative n squared pi squared t over 144. Okay, here you need to add one more thing for n equal to 1, 2, 3 until infinite, because it is still in terms of n. Okay, after we apply the superposition principle, we don't have to write this over again, because we substitute it with summation here, summation n from 1 to infinity. And here you need to define what a naught is equal to C4. Okay, what is the replacement? Okay, and the last condition will be the third condition. Okay, u is not equal to 2x, the initial condition. So here t equal to 0, substitute t equal to 0. So here exponent 0, and hence we have this equation later on, which means here we can refer to Fourier cosine series. Okay, back to the Fourier cosine series here, we have fx equal to a naught over 2 plus summation n from 1 to infinity a n cos n pi x over L. So it suits here, okay? And from here, as you can see, a naught, a capital letter A naught, is at the place of small letter a naught over 2. Okay, here I've written it here. So, therefore, 2a naught, okay, because, okay, this is the formula for small letter a naught. Okay, 2a naught is equal to small letter a naught then. Okay, is equal to 2 over L. Integrate from 0 to L, fx with respect to x. Okay, and then here, we just need to substitute, okay, to find 2a naught is equal to 2 over 12. Integrate 0 to 12, 2x with respect to x, because fx is equal to 2x. Okay, integrate, so we have here x squared, because I have simplified the function, and substitute upper boundary minus the lower boundary, and here we have 2a naught equal to 24, which means a naught equal to 12. Okay, next, a of n is equal to 2 over L, 2 over 12, integrate 0 to L, so that means 0 to 12, fx to x, times cos n pi x over L, so cos n pi x over 12 with respect to x. Okay, the algebraic function will be at the place of u, so you need to differentiate until you get 0. And for v, you need to integrate the dv to obtain v. Okay, integrate and differentiate accordingly. Okay, and please remember the diagonal line. Okay, therefore here we have a of n equal to 1 over 6. Okay, 2x positive, 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 so 24x and pi sine n pi x over 12 plus positive, negative, negative, 2 times 144, 288 over n squared pi squared cos n pi x over 12. Substitute the value from 0 to 12. Okay, substitute each one of them. So you will have this equation then. Okay, and simplify, we will have an equal to 24 over n squared pi squared cos n pi minus 1. Okay, and lastly, therefore uxt equal to a naught that we have obtained earlier, 12, plus summation n from 1 to infinity. Just rewrite your an back again here. Okay, 24 over n squared pi squared cos n pi minus 1 cos n pi x over 12. Okay, exponent negative n squared pi squared t over 144. Okay, that's it for this example. Okay, thank you for listening to me for 50 minutes. Okay, hopefully you understand how to solve this type of question then. Okay, thank you. Assalamualaikum.